Hi guys. Okay, the function a root x plus b minus c, where a, b, c are positive constants, has a domain of -3 to infinity. The function inverse of g has a domain of 7 to infinity and intersects g at only one point. What? It intersects g at only point. I'm assuming that means only one point. Find g of 97. Okay. So first off, it has a domain of -3 to infinity. So that means that x plus b is always greater than or equal to, no, x plus b, when x is -3, it is equal to 0. So -3 minus b is equal to 0, b is equal to 3. Okay, so g of x is equal to a root x minus 3 minus c. Function, the inverse has a domain of -7 to infinity. Okay, so the inverse of g, we're going to write it this way. We're going to say x is equal to a root inverse of g of x minus 3 minus c. Okay, so x plus c over a squared plus 3 is equal to the inverse of g. How does this have a domain of -7 to infinity? Why can't I put like -12 in here? Well, because this is well, we know x is always greater than or equal to -3. So if we put that in here, is that basically saying that the range of this? I think that's saying that the range of g is -7 to infinity. So that would mean that c is -7. Yeah, because if you were to imagine it visually, this is like, it would be like this. And the other one, you rotate it about this, would be like that-ish. No, it'd be, this would be at -7, so it'd be like that. They intersect at only one point. So I bet it's gonna look like this, where it's like this, or I'll just draw on this graph. It's like this, and it's gonna be like that, where they intersect right there. But how do I figure out where they intersect? Set them equal to each other. So, it's not A, it's gonna be, or no, it's still A, but this is -7 plus, and this is gonna be -7. Wrong one. Wait, what? It's gonna be x plus 7, actually, yeah. Okay. C is equal to 7. So we have a root x minus 3 is equal to x minus 3 minus, wait, give me a second. Okay, I'm back. Okay, so this is equal to x plus 7 over a squared I think it should be x plus 3. Because we're saying x negative 3, yeah, x plus 3. This is x plus 3. This is minus 3. X plus 3, and then here we have minus 3. This is 7. Okay, so add 4 to both sides, we get a root x plus 3 is equal to x plus 7 over a squared plus 4. Square both sides, we get a squared times x plus 3 is equal to x plus 7 over a squared plus 4 squared. Oh my god. Okay. So what this is basically saying is that this is only true for one value of x. Okay. 0 is equal to x plus 7 over a squared plus 4 squared minus a squared times x plus 3. Okay, 0 is equal to x squared plus 14x plus 49 over a squared plus 4 squared minus a squared times, I guess just a squared x minus a squared a squared 3. So if this only has one solution, then the determinant is equal to 0. So b squared minus 4ac is equal to 0. What's the different b's? b1 squared, a1 squared, c. So if we can find these, this a, this a, this a, this b, this a, this c, then we can figure it out. But this is not a quadratic, this is a quadratic. Let's maybe find g of 97 in a better, more understandable way. It's a root 97 plus 3 minus 7 minus, and then minus 7 plus 3 minus 7. So this is 100. So we have a root 100a minus 4 is what we need to figure out. So what's a perfect square 4 away from a multiple of 100? It could be a decimal as well. It could be like 0.25, a quarter, no. Can it be not 1/10? Okay, so it can't be 50, no, 25, no, 10, no. Okay, not 75 either, not 90, not, maybe 40, 0.4. 0.4 times 6 is not a integer. Okay, think about multiples of 100. 196 is 14 squared, I think. 196 is, okay, 14 squared is 100 plus 80 plus 16, so I'm just gonna guess that a is equal to 2, so we have 2 root 200 minus 4, 2 root 196, 2 times 14 is equal to 28. So if it gets 28, that could be a viable answer. Is there any way, I just want to use this information that g and the inverse only intersect at one point. How do we know what point they intersect at? We could say y is equal to, maybe let's, yeah, just a root x plus 3 minus 7. Or other one, y is equal to x plus 7 over a squared minus 3. How do we solve this? I mean, we could go simple, add 4 to both sides, add 3 to both sides. Then we have this. This is a very complex equation. If we assume 2, that doesn't really solve anything. This is very likely to be an integer, I think. If this is an integer, then this square root must be an integer because a is not going to be a square root. Yes. So, let's say x is equal to 1. Does that work? We get 4, so 2a minus 4. This is equal to x squared plus 14x plus 49 over a squared. So x is going to be larger. Let's say x, I think? I don't know how these can ever equal each other. Because the thing is, if we make x large, then there's this x squared term which will get extremely large. But this already has the 49, so it's like very large already. Then does that mean that a has to be pretty large to make this equal out, I guess. How do we know where they intersect? Well, we're told they only intersect at one point, which means that if you subtract this, if you subtract one of these from another, they only equal 0 at one point. It's a quadratic, it's some kind of polynomial with a downwards thing at one point. A vertex on the x-axis. I'll be right back. Okay, my only idea for how to solve this is if you say x 1 over a squared times x squared, it's going to be x plus 7 squared. And then we subtract this, minus a root x plus 3 plus 4. Multiply by a squared, we get x plus 7 squared, minus, it's going to be a to the 3, x plus 3 plus 4a squared. I really have no idea. I'm just gonna guess 28 because that's a viable answer we got, but I'm not sure at all. Let me check. Cool, I didn't get it right. It was 17. but I think, well, let me make sure I check. Yeah, okay, I got 7 and 3 correct, but this was 4, so I don't know, I think I was kind of close. Anyways, thank you guys for watching, I will see you guys tomorrow. Bye.